Well, before we begin, I would like to make sure you have the materials that you're going to need for this review of Lesson 1, What is Heat, out of our science textbook. You can find this starting on pages 461, and we're going to go through 461 through the information on through 465. The key vocabulary words that we're going to identify here are temperature, thermal energy, heat, conduction, convection, conductor, and insulator. The science concept for this lesson is how thermal energy moves. So if you don't have your science book or your science journal, please pause the video and get your materials ready before we begin. So what I want to do right now is go over the vocabulary words that we have right now and introduce you to the concepts that we're going to be covering today. So what we're going to be looking at is what is heat. So we have to identify a few things first before we start. We have to identify what temperature means, and temperature is the measure of how hot or cold something is. And we usually use a thermometer is what we mostly is used to measure temperature. Okay, and thermometer is divided into degrees like so. Okay, we have to look at what thermal energy is. And thermal energy is a form of energy that moves between objects because of differences in temperature. And here you see a blow dryer, and you can see how the heat is being visualized here. You can see how the blue is colder, and of course the yellows and the reds is the heat right here, and here is the temperature here. So as it projects outward, it starts to heat up the air, and notice the air around it. It's black because it has not received any of that thermal energy. So we looked at what temperature means and what thermal energy, okay? And we know that it's moving between objects because of differences in temperature. So this was cold before. As soon as we turn on the dryer, now it's hot. So we're looking at what a conductor is. A conductor is an object that heat can move through easily. For example, water is a conductor, and metals is all the different types of metals are also good conductors. There are some objects out there that are not good conductors. That means heat will not move through them easily. So right here, what we have here is a couple of the vocabulary words that we're looking at. We're looking at conduction and convection. So before we start, conduction is the movement of thermal energy between objects touching each other. And this is the example right here. This pot is being heated by this hot coil here. That is called the heat, is called the radiation that's coming out. It starts heating the bottom of the pot. And conduction is how the heat is transferred from the pot to the handle. Now, when I was younger, these pots were made out of aluminum or steel or tin. The pot, this section here, was made out of tin, and so was the handle. So we were taught from very young ages not to touch the handles when something was on the stove, because you touch this, conduction created the thermal energy moved through here, and this whole handle was the same temperature as the pot here. There were several times that Mr. Lopez would forget when he was cooking when he was young. He'd touch the handle here and cause some burns. Um, that that happened quite a bit when I was young. But that's why, because now they don't have these handles made out of metal anymore. They're made out of plastic. Some are even made out of wood. And plastic and wood are not very good conductors of heat, so they stay cool to the touch. The pots are still the same. They still make them out of metals here. So that's conduction, how it moves. The thermal energy moves from between objects touching each other. Of course, if you were to put something, say a cup or a plate near the radiation that's coming out, the heat, of course, conduction would cause the plate or the cup or the mug to also begin to heat up. Then we look at convection. Now, convection is the movement of heat because of the movement of warm matter. the movement of heat because of the movement of warm matter. And this is an example here when you put cool water and you start heating it up. The hot water here at the bottom starts to heat up. It moves up as it heats up, and then as some of the water here cools down, it goes down and the cycle continues. Okay, and as it continues, that is called convection. Now we also have convection uh, inside the Earth's crust because it's not just water, it's matter, and the matter that's inside the Earth's crust is the magma. And the core is hot like this stove here. It heats up the magma goes up, comes out in volcanoes or in cracks in the Earth's crust, and as the plates move up underneath one another, the rocks begin to go and move down into the magma chamber and begin the process all over again underneath the Earth's crust. So that is convection. Convection is the movement of warm matter. And it goes from hot and it cools and it goes back down again eventually until all of this, once you do keep it here for the longest time, the water keeps moving. If you ever notice water boiling, there's movement to it. There's movement. The convection continues so long as you apply heat to it. The minute you stop applying heat, the convection slows down. So to review, conduction, the movement of thermal energy between objects, like so. Objects that are touching each other or close to each other. They don't necessarily have to touch. It could be close to one. And convection, the movement of heat because of the movement of warm matter. This is an example here. So we have conductors. Those are objects that heat can move through easily, like the metal here of the pot. Heat can move easily through here, and so it can it through water here, but not through the plastic. It cannot move as easily. So we need to look at the next section in the textbook that talks about insulators. An insulator is an object that doesn't conduct heat well. And some of the examples is we have wood, cloth, and plastic. For example, some of this spoon here. When we used to have these uh, pots here when I was younger, a lot of times we would leave the spoons in the pot as it cooked, the metal spoons, and then we would touch the metal spoons, and if we weren't careful, we would burn our fingers or our hands again. So we were taught to not leave the metal spoons in the pot while it's cooking, and those are kind of things that we learned as we were growing up and we're cooking, learning how to cook. I learned how to cook from my grandmother, and so those are the kind of things you learned right away. But when we have wooden spoons, the heat is not conducted through these objects very easily. So this can be left inside the pot and it necessarily will not be hot to the touch as opposed to if it were a metal one. Now cloth also is a very good insulator. That means heat won't move through it very easily. That's why we have those oven mitts made out of cloth so that you can put them on and touch an object that is hot. Plastic is also not a good conductor, but it's a good insulator. So a lot of the hard plastics are now used as the handles on a lot of the pots and pans that we use for cooking now. So these are insulators. Insulators do not conduct heat well. That means the heat doesn't move through them very easily, as opposed to the metals or water. So in order to look at this, so you can apply these concepts, try this experiment at home. But be very cautious here. Put on your safety goggles and have your parents supervise you because it's going to entail having hot water. So gather the following materials before you start. You need 3 styrofoam cups, 1 wooden, plastic, or metal spoon. And I've come to find out here that these wooden spoons are not very readily available unless they're nice and large. So if you don't have a small wooden spoon, go ahead and substitute the wooden spoon with maybe a popsicle stick. Okay, popsicle stick will be a good alternative to the wooden spoon. It's what we want to do is test the conductivity of the spoon, the plastic, and the metal spoon. You're going to need half a liter of hot water. Be very cautious with this because the hot water is hot. Be very careful with hot water. You want to have everything laid out in front of you so that you are safe from the hot water. So before you start, you're going to have your journal. Everything covered in this presentation here needs to be added to your journal. And as you go through the pages in the science book that correlate with this presentation, you also have highlighted words and general information that you can jot down. But what we reviewed here is mostly what's in that section. But be sure to review it as you look at this presentation. This experiment is in the beginning of the lesson in your textbook. I just modified it a little bit, okay? We're only doing the ones with the cups. So what we're going to do first is once you get everything ready, fill up the 3 styrofoam cups with hot water, and you're going to place 1 spoon in each cup. But before you do that, I want you to touch the 3 spoons and record your observations. So before you put them in the hot water, grab them in your hand, touch them, feel them, and record what you are observing. And again, you're using one of your 5 senses here, which is touch. How are they feeling? Are they hot? Are they cold? Are they at room temperature? Just explain it to me and describe it to me. That goes in your science journal. Okay, you're going to be using your science journal to record this information, as well as the information covered in this presentation and in your textbook. So once you record how the 3 spoons feel before you put them in the hot water, then you can start filling up the styrofoam cups with hot water. Then you'll place one of these spoons or metals or popsicle stick instead of the wooden spoon. You're gonna put 1 spoon in 1 cup, the other spoon in the other cup, and the other spoon on the other cup. So you're gonna have 3 cups, 1 with the wooden spoon or popsicle stick, 1 with the plastic spoon, and 1 with the metal spoon. You're gonna wait for approximately maybe a minute, or maybe wait a little bit more, a minute and a half. Wait and see which one of those objects conducts the heat more efficiently. So you're gently going to touch each one. You're going to touch each one of the objects from each one of the cups. And you're going to draw a conclusion about the way thermal energy travels through different substances. And explain what you concluded. After touching the 3 objects, what did you find out? Explain to me what you observed when you touched the metal spoon. Explain to me what you observed when you touched the wooden popsicle stick or wooden spoon. And explain to me what you observed when you touched the plastic spoon. Okay, so you would draw a picture of each. You would make sure that you use your notebooks if you need to revert to any of the information covered there. For example, if you want to use some of those vocabulary words, make sure you revert to your notebook, your textbook, and use those vocabulary words in your conclusions and your descriptions of what you observe. Very simple science experiment here, but you're going to find out how conduction works with different objects. Now, for your science conclusion here is you're going to have everything recorded in your science journal. You're going to have the definitions recorded in your science journal. You're going to have pictures describing what the vocabulary words mean. And you're going to have the results of your science experiment. Okay, this is a very simple experiment. It does not take a lot of time, but it gives you a very, very good picture of what conduction and what heat is and what convection is, thermal energy. And it's a very easy way for you to see this. Again, if you have any questions or concerns, or if you feel that you want to create a presentation to show to the class, feel free to transfer the information that you have in your science journal into a Google Slides document or a Word document, and you can share it with us during our live streaming sessions. Well, thank you again for your time, and again, refer back to your textbook if you have any other questions related to this topic.